equations in. Does anyone know what kind of form these two equations are in? Roy, standard form, okay? And standard form, the reason standard form is helpful is because we can calculate the y and x intercepts very easily, okay? So since this is in standard form, all we're gonna do is we're gonna plug in 0 for x to find the y-intercept, and we're gonna plug in 0 for y to find the x-intercept, okay? So this first equation will be my red line, and the second one will be my blue. So for my red line, we've got 2x plus 3y equals negative 17. Let's plug in x equals 0. This will give us our y-intercept. This is going to be 2 times, if x is 0, now we just plug in a 0, plus 3y equals negative 17. We're going to get 3y equals negative 17. How do we solve for y? Divide by 3. So y equals negative 5 2/3. And then we also have to plug in y equals 0 for what intercept? The x-intercept. So we're going to get, instead of 2 times 0, it's going to be 2x plus 3 times 0 equals negative 17. From here, 3 times 0 is just 0, so we've got 2x plus 0 equals negative 17, or 2x equals negative 17. We divide by 2, and we're going to get x equals negative 8.5, or 8 1/2. No, but in order to graph it, it's easier if we write it as a mixed number like that. Okay, so that's our first one. Let's go ahead and graph that, okay? So I'm going to draw a y-axis down here and an x-axis. And then we need to go, and our y-intercept is negative 5 2/3. So let's go down 5 2/3. So 1, 2, 3, 4, 5, 6, somewhere over here. And then for the x-intercept, it's at negative 8 1/2. So let's go to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, right between 8 and 9. Negative 8 and negative 9. So here, guys, all we're going to do is draw a line as best we can, make it really long through both of these points. Okay? That is how we plot. That's why standard form is so nice sometimes. It's because you can find the x-coordinate or the x-axis, x-intercept, and the y-intercept, and then just draw the line between them. Yeah, absolutely. So if you wanted to change those two equations into y equals mx plus b form, which is slope-intercept form, you could have done that 100%. You would have gotten that your y-intercept would have been negative 5 2/3, and your slope would have been like negative, what'd you get, Roy?
I did it your way.
Oh, you did it my way? Okay. But you would have gotten like that your slope was like negative 3/2 or something. Or no, negative 2/3. Okay, for the blue line, okay? Now all we're gonna do is do the same thing since it's also in standard form. So we're gonna write 3x plus 2y equals -8. How do we find the y-intercept? Good, plug in 0 for x equals 0. If x equals 0, we've got 3 times 0 plus 2y equals -8. Tessa, help me out with this one. How am I gonna finish this one? And then what do I do? Beautiful. Divide 2 on both sides. We're going to get y equals -8 divided by 2 is just -4. Excellent. Let's just go ahead and plot that right off the bat. So let's find y equals -4 and just put a point there in blue. Okay? Next one. Nicole, in order to find my x-intercept, what do I have to do? So for my y-intercept, yes, y equals 0.
And then it would be 3x plus 2 times 0 equals -8.
Awesome.
And then it would be 3x equals -8, and you divide them both by -3. Yeah, -3, right? What do you get? 3?
What do you think?
Yeah, 3.
Okay.
And then you...
So not -3? 3 or -3? What do you think?
3.
Okay. Why?
Because the 3 is positive.
Uh-huh. You don't want it to be negative, right? Because if we divided by -3, we would get -x, and that would be weird, okay? So let's just divide by 3. What do we get? You can leave it as a fraction.
X equals...
Yep, -8/3. Now, for our purposes for graphing, we're just gonna figure out how many times 3 goes into 8 without going over, and that would be 2, right? Because if it went in, if it was 3, that would be 9, and that would be over 8, okay? So we're gonna just put it in 2 times, so we're gonna get -2, and we'll have 2/3 left over. So -2 and 2/3. Okay, so let's find that x-intercept. So our x-intercept is at -2 and 2/3. That's going to be right here. So let's just go ahead and draw a line through those 2 points. Kind of like that. Now, in Notability, it's a bit easier because you guys can draw straight lines. For me, it's a little bit harder because I'm using a different system. But of the answer choices, which one do you think is this point over here? Where the 2 graphs cross. Because remember, that's going to be our solution. Roy, what do you think it is? 2, -7. Why is that our answer choice? Just by looking at the other answers. Yeah, all the y's don't go down that far. And all of the x coordinates for the other ones are negative, right? Aren't we in the positive side for x? Because you see how this dot lies to the right of the y-axis? Okay, so our x coordinate had to be positive, so our answer had to be 2, -7. And if you guys were to do this on actual graph paper, you would see they would intersect directly at 2, -7, okay? I didn't use graph paper, that's why it's a little sloppy, okay? Number 44. What'd you get, Janessa?
G.
You got G? How'd you get G?
So I put 5m minus 12 plus 8.
Mm-hmm.
And then, like, I put that arrow above.
Okay.
m,
What does that mean? What do we call that?
5 times m.
Yeah, but what do we call when we multiply to both terms? There's a special word that starts with a D.
Distribute.
Yes, we distributed. Very good. Okay, I agree with you up to here. What'd you do?
5m minus 12 plus 8. And then I left 5m the same.
Mm-hmm.
And then I added 12 plus 8, which is 20.
Okay.
So I got 5m minus 20.
Okay. When we distributed, you distributed to the M, okay? Super happy with that. And I'm super happy you drew another arrow, but we have to do what the arrow tells us, right? Did you multiply 5 and 12?
No.
Ah. So instead of that minus 12, what should we have there?
60.
Ah, there we go. So let's erase that and put minus 60. You were so close, okay? So minus 60. So instead of minus 20, what are we going to get, guys? We've got negative 60 plus 8.
60. 5m minus 68.
Remember, one's negative, one's positive.
5m minus 56.
There we go, minus 52. What answer is that?
5.
I. Okay? Very good, Janessa. Does everyone see 44? Any questions on 44 or 43? All right, guys. So in this method, we're going to use, instead of graphing, we're using substitution, okay? So just like how you would sub in a game in soccer, okay? We're just subbing for a variable in these equations. So to solve systems of equations using substitution, that is our objective, and we're going to see how it works. Okay. So, solutions of equations can be solved in more than one way. When a system has at least one equation that can be solved quickly for a variable, the system can be solved efficiently using substitution. And this is an example where we used substitution in our problem, okay? I'm gonna add some notes on the side of this problem. So over here on the right, the first thing that I want you guys to do is find out if there's a variable with no coefficient. Is there a variable with no coefficient? Okay, so remember, a coefficient is just, is there a variable with no number in front of it? Okay? Now, in our case, we have 3 of them, right? So our second thing we have y, we have x, and we have this other y, okay? The second thing we're going to look for is, are any of them isolated? That means, are any of them by themselves on one side of the equation? So second thing, are any isolated? And what's the only one that's isolated? This first y, okay? So we're going to use that one in terms of our substitution. If you guys want to think about it in a different way, think about like, you know when you're subbing in a sport, it's because you're tired, right? Maybe you're lagging behind, you're not running as fast. On the basketball court, you're the last person back on defense. On the soccer field, you're like the one that's missing in action, okay? Because you're getting tired, you're getting slow. You need to be subbed out. So the one variable that's by itself with no coefficient, it's got no help, that's the one that we're going to sub, okay? So you're going to use y equals 3x as our sub. What we're going to do is we're going to take y equals 3x and we're going to plug it in wherever we see y in the second equation. So where we see x plus y equals negative 32, wherever we see y, we're going to plug in 3x because y equals 3x. So take a look down here. Wherever they had that orange y, they just put a 3x. So they had y here, and they plugged in 3x. So x plus y equals negative 32, x plus 3x equals negative 32, and then you just solve that equation. And then they got x equals negative 8. Once you get x equals negative 8, you can plug that value back into either expression, either the first or the second equation. And then once you do that, guys, you can solve for y. You're going to get y equals negative 24. And then from there, you've got an ordered pair solution. Okay? So the reason these are different is because before, right, we would graph and we would find out where they would intersect. We're still getting that point, right, where they intersect, but we're not graphing it. We're using a method called substitution. Okay, let's check out a real example. We're going to do it. What is the solution of the system? Use substitution. Okay, do we see a variable without any coefficients? Ashton. Yes, how many? Not just one. Nicole? Very good. We've got this y, and which other one, Nicole? The x, very good. So we've got 3 variables without coefficients. Which are any of them isolated? Which ones, Roy? Both the y's are isolated. So guys, that means we can use either one, okay? When both the y's are isolated, you could use either one, okay? Now what I'm going to do is I'm going to use the first one. I'm going to use y equals 2x plus 7 as my sub. Okay, so that's the one that's getting tired. That's the one that needs a sub. So wherever I see y in the second equation, let's write the second equation again. Y equals x minus 1. Wherever I see a y, I'm going to plug in 2x plus 7, our first equation. Okay, wherever I see a y, I'm going to plug in 2x plus 7. So this instead becomes 2x plus 7 equals x minus 1. Wherever I saw y in my first equation, I plugged in 2x plus 7. That is what we call substitution. Okay, once we have this equation, how do we solve it? 2x plus 7 equals x minus 1. What can we do? Let's see if we can figure this out together. What do you think, Roy? Take away the parentheses. Okay, so 2x plus 7 equals x minus 1. Why were we able to take away the parentheses, guys? Very good. There's nothing outside the parentheses to distribute, so we can just take them away. Giancarlo, what should I do next? Let's move the variable all to one side. So do you want to subtract, what do you want to do?
Minus x.
Okay, let's subtract x from both sides. Angelina, what am I going to get? Yeah, 2 plus 7 equals negative 1? Okay, so I agree that this x cancels, right? So that was good. But 2x minus x is not 2. What is it? Janessa, what is it?
2x minus x.
Yeah, what's 2x minus x? It's not 2.
Negative 2.
Nope. Ashton.
X.
X, okay? If you have 2 pizzas and you take away 1 pizza, how many pizzas you got? 1, okay? So we've got 2x minus x, that gives us x, so we've got x plus 7 equals negative 1. Okay, I've got one more thing I need to do. How do I do it? Giancarlo, what do I do?
Yeah, minus 7.
Minus 7. Nicole, what's my answer?
Negative 3.
X equals negative 8. Okay, so we found our x coordinate, so we're golden here. X equals negative 8. We can plug it into either of these expressions. Victoria, do you want me to plug it into 2x plus 7 or x minus 1? X minus 1. Okay, so we're going to take y equals x minus 1. We're going